In this section, we're going to begin our introduction into object-oriented programming. There are three programming paradigms that have been discovered. First is structured programming, second object-oriented, third is functional. All three have been known since around the 1950s, 60s. Java provides the ability to program in all three of the paradigms. Our focus to this point has been on the structured aspects of Java. Now we're going to shift into object-oriented paradigm, building upon the base of structured programming. Structured, or as it's sometimes called, procedural programming, was designed after research into programming structures. It organizes problems in a logical, readable, maintainable way that solves some significant issues. Structured programming tends to limit the control flow of a program. We discuss sequence, selection, and repetition. The design and implementation of structured methods is on how they manipulate data that is external to them. Any method can access the data, any method can modify it. That makes programming straightforward but dangerous because a method can inadvertently or maliciously modify data that it has no business accessing at all. Object-oriented programming solves that invalid access issue by restricting data to objects. Those objects maintain their own data. Only they can manipulate it. They may or may not allow external code to see those values. In some cases we do. In many cases, we don't allow it. The object-oriented approach better represents real-world entities. For example, the human body is assumed to have a heart and a brain, although under normal conditions, we do not see them. We know they're there by their effect. In object-oriented programming, we abstract real-world entities. That is, we take the minimal number of attributes or characteristics to model that and use those. We don't model everything possible. We define data, that is what an object knows, and its behavior, that is what an object does. Usually, some or all of this data is encapsulated or hidden away inside the object, inaccessible by external code. This means we present an interface to the external code that, like a human body, we have hands and legs and feet and abilities to speak and whatnot that are the ways that the human interfaces with the outside world, yet all the complexity is inside. Objects relate to each other by sending messages. Often they're just method calls, and they can be associated in hierarchies where sharing of code can be done by what's called superclasses and subclasses. We have a way to reuse existing function that's already working in new classes as we need to enhance the abilities of objects to do additional things. Further, they can behave like the object they actually are, even though they're treated as something else in the hierarchy. A subclass can act like a superclass, yet form specific behaviors precisely its own way. That's called polymorphism, or multiple shapes, multiple forms. And finally, just as an aside, the third programming paradigm is functional programming. Java has abilities to do some limited amount of functional programming built in as of Java version 8. One of the original functional languages was Lisp, still very valid. A modern derivative is Clojure. Functional programming, oddly enough, was the first paradigm discovered, and it's the least well understood. If you have the opportunity to grow in the functional area, I would advise it. You're going to be good at structured programming. You're going to become good at object-oriented programming. My encouragement is continue with functional. Know all three paradigms.